And here we go. We have liftoff.
Propulsion continues to be nominal.
R68 chamber pressure looks good.
Doubling up. Roger, with Planet.
Water towers fly! Yes!
Tango down to nominal.
Fighting down to FD off. Bring in FD off. Off. It's orange!
Oh my god! Oh my god!
Decollage. Put that in the big bag, Eagle.
343 unfolds to go.
Indeed.
We rise together, back to the moon and beyond.
If the methane would be igniting in the flare, correct?
Yikes. You read? We don't need any more of these.
Good evening. Seeing all the hype for that intro, you are looking live right now at Space Launch Complex 40 at the Cape Canaveral Space Force Station, where a Falcon 9 rocket is ready to launch the Intelsat 40e mission along with a special payload called Tempo. Looking forward to seeing all of those 5x5s in chat, which I do see, including the new emoji there, I guess that's what they're called, yeah, that you can hear us loud and clear. I am Sawyer Rosenstein. I will be your host for this evening's broadcast, and joining me tonight in the studio here, we have with us Alicia Siegel. How's it going, Alicia?
Hey. So great to be joining you. And wow, that new intro was fire. Gosh, I was not expecting to see that tonight, but all right. Very nice, guys. Very nice. But yeah, excited to be launching some cool science up into space tonight.
Absolutely, and we are so glad to have you back on another broadcast.
Yeah, glad to be here.
And we have another fantastic person with us. They are out in the field, and that is Julia Bergeron. Julia, how's it going?
Why, hello there, Sawyer. It is a beautiful night here on the Space Coast. I am located tonight just off US 1, roughly 12 miles away from the pad, and I'm really excited to join everyone tonight.
We are glad you're here, and also in the field for us, operating the cameras that will hopefully be tracking the launch manually at least, is Max Evans. And then also behind the scenes, the man pulling the levers, pushing the buttons, and getting the photons where they need to go is, of course, Patrick Calhoun. So we've got a great team for you tonight for this Intelsat 40e mission. So if you have any questions, remember, you can tag us at NASASpaceflight, and we will do our best to answer as many of them as we can. At this point, we should be preparing for fueling to begin in just a couple of minutes. But let's talk about the payload itself. So I'll talk about Intelsat 40e first, which you may remember we've talked about the great geostationary replacement as a result of a lot of the 5G signals that are being changed by the end of the year. There's a lot of new satellites that are going up into geostationary transfer orbit, and this is one of those. But attached to it is a really cool NASA payload. And Alicia, I'm going to hand that over to you. If you could tell us a little bit about Tempo.
All right, sure. So TEMPO stands for the Tropospheric Emissions Monitoring of Pollution Instrument. And yeah, it's going to be a hosted payload, which means it is basically going to be hitching a ride on a communication satellite. So Intelsat 40e will be going up. It'll be providing coverage over North America for things like commercial aviation and maritime and land mobility. And so Tempo is going to be along for the ride. But here's the important part. So the satellite is ultimately going to settle into this geostationary orbit about 22,000 miles above the equator. And that essentially means it's going to orbit in lockstep with the Earth's rotation. So it's going to look like a fixed position over North America 24 hours a day. And normally, when you have satellites in low Earth orbit, they're constantly going around the Earth, maybe, 16 times a day. And that means that it may only even pass over any, one given area maybe once a day. So it really limits the data you can collect when you're trying to do science. But with this geostationary vantage point now, it's going to be able to sweep the entire continent every hour. So it's going to show you from Puerto Rico and Mexico all the way up to Canada and across the US from the Atlantic to the Pacific. And it's going to be picking up really small details too. The spatial resolution that they're going to have on this thing is down to just about 4 square miles. So previously, they're looking at something like 100 square miles, but now we are focused even more into like the neighborhood level, which can make a huge difference to be able to pinpoint, even specific pollutant sources like factories and power plants, or even certain roads at specific times of the day, which is ultimately what this will be doing. It's looking for pollution. And you think about, for example, like the glorious chaos of New York City, where I live. If you only happen to collect data at 1 in the afternoon, or even at 1 in the morning, you might be completely missing things like rush hour traffic, for example. And also spatially, you're maybe just getting a glimpse of the factories that are raining poo across the river in Jersey or whatever. And that's going to look very different than observing something like a rock and some trees in the middle of Central Park. So having this much, finer attunement really helps us to lead into a better understanding of how the Earth works as a system over time. And we can develop better predictive models and tools for decision makers. And this is actually going to be 1/3 of a global air monitoring constellation with some sister satellites. So currently we've got the Korean GEMS satellite, stands for Geostationary Environment Monitoring Spectrometer. It's a mouthful, that launched in 2020. That currently takes measurements over Asia. And then we've got another one called Sentinel-4 that is expected to be launched in 2024 next year. And that specifically is going to be covering Europe and Northern Africa. So we'll get, this larger global picture in the coming years for sure. Because guys, reducing air pollution isn't an easy task. It's emission.
Oh, that was good. I like that
First of the
one.
night. Let's go. All right.
Oh, we'll
Anyway,
be sure to
so
keep the tempo of jokes up.
There you go. So the geostationary orbit is really kind of the essential thing. It's going to be at 91 degrees west longitude. And that'll be really helpful. And then in terms of the actual science, so first of all, if you're curious of the size, it's about the size of a washing machine, they say. And it works by measuring sunlight. So it's measuring sunlight that's reflected off particles in the atmosphere. And then it takes that and it separates it into about 2,000 component wavelengths. And then scientists can use hyperspectral data to determine concentrations of trace gases that are present there. And they actually currently do this when they're looking at, exoplanets and stuff too. So it's specifically going to be measuring ultraviolet, visible, and near infrared light. They're going to be looking at pollutant levels of things like ozone and nitrogen dioxide and aerosols and formaldehyde and all these things across North America every hour during the day. And then what else is cool is they're going to be using Tempo to track pollution caused by natural events as well. So things like wildfires and volcanic eruptions. And in one group of studies, they're actually going to be looking at things like the behaviors of marine-based phytoplankton and red tides. There's harmful blooms of algae out there. And they'll also be looking at emissions from fertilizers out on crop farms and water cycles, and how pollutants can be spread even by things like storm systems as well. So this is going to be a really helpful thing to keep an eye on how pollution is spread around our planet.
Yeah, and I think the biggest factor in that's really cool is that this is the first time that we'll have real-time hourly updates as opposed to maybe once or twice a day. So we can know in real time if there's a fire spreading or something, how it's affecting the atmosphere.
Absolutely.
I love it. So while we're looking at the rocket on the pad, we are about 32 minutes until the liftoff, and as of right now, we did get confirmation that the launch auto sequence has started, so fueling is underway on the rocket. By the way, which booster is this, and where's it going to be landing, Julia?
Oh, hey, Sawyer. So this is booster 1076. It will be the fourth flight of this booster, and it previously, its first flight was on CRS 26. Then we did OneWeb 10 and a Starlink, because I don't know if there's really very many boosters that haven't seen a Starlink launch yet. But we're going to be landing on a Shortfall of Gravitas, which is positioned downrange about a little bit more than 600 kilometers. When I say due east, I mean due east of where we are. I'm not sure if we have a graphic exactly to show us that, but due east of where we are, which means my view will be a line in the sky because I am looking east right now.
And there is that graphic, by the way, so we do have it on screen. So keep in mind if you have questions about whether you might be able to see the launch or not, it's not going northeast like a space station mission or southeast like a lot of the Starlinks recently. It is going due east, but should put on quite a good show tonight. I want to take a second here and thank some of the people that are supporting us through Super Chats. We have Moldy Space Industries gifting 5 Red Team memberships, and T. Evans NC gifting a Red Team membership as well. Thank you for that, and if you are gifted a membership, please make sure you thank whoever gave it to you. Wolfram with Let It Roar, like this bird and let it soar. I have a feeling that's to the tune of Frozen, but I don't want to get copyright struck or made fun of tonight, so I will just read it like it's a Jeopardy clue.
Nice.
Question here from JD Brown with the support as well. And Alicia, I'll hand this one over to you. Is Tempo just an attachment to the payload, and why did they choose not to make another satellite, but rather add a simple instrument that can be attached to one?
So this idea of hosted payloads is something they've actually been looking into for a while now to keep costs down. This in particular it costs, I believe it's $90 million for Tempo itself. And then in total with, the rocket and the sharing and everything, it's like $210 million. But it's just a way to, kind of spread the costs around and keep it a little more manageable because of course this is a NASA funded situation here. Does that answer the question though? Essentially, like they're trying to see if they can do this more, having this this hosted payload situation on satellites versus creating their own satellite, which would obviously up the cost quite a bit.
Oh yeah, absolutely makes sense, especially because it is a NASA payload, so your tax dollars at work. And
That's right.
again, it's amazing how for such a low cost we can still get so much out of it back here on Earth. And then Moldy Space Industries with very generous support here. Thank you, Moldy Space Industries, a name we love seeing here. Saying, super excited for Tempo. What's this about, a comsat on the side? Very clever.
Exactly.
And then new intro was awesome. And hashtag Thomas Fan Club, who's not even on the stream tonight, but always showing Thomas that love. I like it. And then Bill Moore with the support as well, saying, thanks, NSF. Well, thank you, Bill, and thank you, honestly, to everyone who's watching tonight. It is only because you guys come in and watch and give us supports and things like that that we can even do what we do and bring you these fantastic live feeds, as we now get to about 26 minutes and 45 seconds or so until the scheduled liftoff time. Now, this was, in a very rare case, a 119-minute window. Julia, why is it that we had such a long window when we're used to something like a Starlink or an ISS mission being a couple seconds?
Well, in the case of a Starlink mission or even an ISS mission, there is a very specific place that this payload would have to be. Either you're going to be going directly to the ISS or you're going to be trailing behind to catch up. And in the case of Starlink, each satellite has a very specific place it needs to go to complete the constellation. In cases like this one, there's a little bit more within this orbit, a little bit more give. And with it staying in that same orbit, we get a little bit more window, which is something we're kind of not used to. If we had a situation where maybe fueling wasn't going as planned, or like we had with the recent launch for Relativity, conditioning wasn't going quite as planned. Once you kind of have to restart a process, we don't get another opportunity because the window just isn't long enough with instantaneous. So it's a rare opportunity, and those of us who are staying up and have to work in the morning sure do hope we're going at the beginning of the window, though.
Agreed.
Yeah, I think all of us feel that way, although I
Yeah.
am a night owl, in case you didn't notice all the night streams I end up being on for these launches.
And there's something about that full moon, or almost full moon, at night that calls to us night owls as well.
Absolutely. Apparently, it also makes it a mess for first responders and nurses and doctors and things like that. But I can say from my mom's experience as a labor and delivery nurse, full moons do affect how busy hospitals get.
Yikes.
Let's see. We have a question here from James Myerscough asking, how does the upper stage put objects into different orbits like this? Do the payloads separate it from it at different times or all at once? I don't know if Alicia or Julia, either of you want to take that or if you want me to take it.
Take it. I mean, it depends on where the payload's going too. But yeah, you could probably take that one.
Yeah, so a lot of it is basically where they target it with the first stage. So you'll notice when it launches on the first and second stages initially that it's roughly the same altitude, but it's not always exactly the same. So sometimes it'll burn a little bit longer, sometimes a little bit shorter. In fact, compared to a Starlink, which Seco, the second engine cutoff usually happens around 8 minutes and 40 seconds or so into flight. This mission is actually cutting off at 8 minutes and 11 seconds. So it's only 30 seconds, but when you're traveling at, hundreds of meters a second, that's a lot in 11 seconds. So a lot of it is that. And again, they do have the second burns that those upper stages will do. And this one does have one additional second engine burn before it's deployed. At that point, the satellite's own engines and thrusters will then take over and get it into its final geostationary orbit. So that's why it launches to geostationary transfer orbit and then goes into geostationary orbit using its own engines. Hopefully that made that clear.
And that takes a while too. That's going to take about 3 weeks to get it up there.
Oh yeah, it really does take a long time to get that exact orbit because you have to be at just the right altitude for geostationary, right? So that it basically stays in one place.
Right, right.
Yeah, it's that perfect Goldilocks zone of the right altitude at the right speed where you match the rotation of the Earth. That's the whole point of geostationary. Big J4 Gaming here with the question, will we get a jellyfish effect due to the full moon? Julia, you're out there. What do you think?
Yeah. That's. I'm kind of looking at the moon relative to the pad, relative to where I am. With it going away from the moon, 50-50. If we get something, it's not going to be until we maybe have the fairings, the little thrusters on the fairings, maybe. I wouldn't say you're going to get a very colorful jellyfish. If anything, we'll see, that spooky white ghost, maybe? Maybe. I'm just going to stay safe on the 50-50 side because it is a bright moon tonight, but it's pretty high compared to where second stage is going to be already. So,
does that mean that we have a jellyfish and a Casper as the two effects now?
I think I'm going to start calling those Casper. Yes.
Nice.
There we go. I know we're coming up on the T-minus 20-minute vent, but Austin Skirvin here with a $5 tip saying, #ChrisXFanClub. Oh wait, might have been going too fast. Anyways, NSF Fan Club. Austin, thank you very much for that tip. And a reminder, that is one of the new ways you can support NSF by going to tips.nasaspaceflight.com. That way you don't have to go through Google, which does take a portion out of it. It goes directly to helping provide you all of this content that you see. And yeah, if you give us tips, we'll keep giving you tips on how to watch rocket launches.
Hey.
I know. That one was terrible. I'm sorry. So we should be coming up in less than 10 seconds now on the T-minus 20-minute vent. So what is this T-minus 20-minute vent that we're so used to seeing here that should be starting any second now?
Are you asking me that question?
Whoever wants to take it.
There it goes.
And just like that, there it goes.
I could take it. It's fine.
Just answer your own question tonight.
Anyway, so to answer your question, Sawyer, the the T-minus 20-minute event is purging of the fueling lines on the transporter erector. So you'll notice now on the graphic there that stage 2 RP1 load is complete. So what does that mean? So the second stage, or the upper part of the rocket, is filled, just like the first stage, with RP1, which is a rocket-grade type of kerosene, and liquid oxygen. So between those two, that's what mixes, and that's when you get your fuel that burns through the Merlin engines. So they've finished loading the RP1 and are getting ready to load the LOX, which is not bagels, it is Loxygen, or liquid oxygen. And so they usually use nitrogen to clean out the vent line and make sure it's ready for its next load of LOX. And that usually lasts this vent for about 4 minutes. You can also see the rocket starting to get very frosty, about a third of the way up now, and that is because the fuels that are on board are super cooled. You're talking negative 200 degrees Fahrenheit in some cases, so it gets quite cold. And it gets frosty and builds up all that ice, which is completely normal, though.
We do love our frost.
Oh, yes, we do.
And I love how every Falcon booster looks like a new booster once it's fueled up now, doesn't it?
It really
Nice and
does,
white and
yeah.
clean.
There you go. You don't have to repaint it. It kind of paints itself, or at least puts a wrap on itself before liftoff. All right, let's see. We've got some support here from Lewis Rogers saying from North Carolina, we are finally sitting 6 miles away from the launch. From the Rogers and Coates, we love you. And Lewis, we love your family too, and hope you guys get to enjoy a fantastic launch. It sounds like it's a beautiful night there. What is the sky looking like by you, Julia, by the way?
It is a dusting of clouds. And when I say a dusting of clouds, I literally mean, for the most part, it is clear. So depending on where you're standing, you might have just a few wisps of clouds, but directly to the east, I really don't see very much. So there is a chance, a small chance at least, that we may even be able to see, heads up, Max, we might even be able to see the reentry burn tonight.
Oh, nice.
Wow, that would be fantastic. And Stank Nugs, thank you very much for your support. We appreciate that as well. Let's see. Let's take another question here. Alicia, I'm gonna put one to you. What are you most looking forward to about Tempo? Because it is such a cool mission, and there's so much that can come out of it. But what in particular are you really excited about?
I mean, I think in general, it's going to be great to be able to monitor, just everything that it's studying over time, right? The fact that we're going to be able to see it across the 3 different constellation satellites will be really great to just to monitor the trends, just the way that the movements of just everything across the planet, like I was saying earlier about like the water systems and just the airflows and whatnot. But also being able to specifically identify which pollutants are coming from where is going to be really helpful just for decision makers looking forward. I also really think that studying the natural things, like I was mentioning the wildfires and, these like phytoplanktons and everything like that, that's going to be really helpful as well. I don't know. I don't know if I could pick just one thing. It's just going to be wonderful to be able to see it on such a very like hyper specific level and just so specifically, which chemicals and whatnot. It's just going to just blow open the doors and like allow us to see things in ways that we've never seen before, which is pretty cool.
You know
I
what,
love it.
Alicia?
Yeah.
I'm kind of excited that the satellite is leaving from Cape Canaveral because I'm looking forward to seeing data on what pollutants are affecting our lagoons right around here and our manatee
Sure, yeah.
population and the red tides that affect the
Yeah.
Gulf. So
Yeah.
those are all going to be interesting for me to see, kind of like how we have the satellites, the GOES satellites that have helped us so much give perspective to hurricanes.
Mm-hmm.
I think this will be enlightening locally as well.
Yeah.
And a couple updates for mission control. At this point, stage 2 LOX load is underway, which is also visible in the fact that the vent has stopped. So the liquid oxygen is now loading into the second stage, and we're also getting word that the main satellite, Intelsat 40e, is on internal power and that the spacecraft is go for launch. We will continue to keep tracking the rocket itself as it prepares for launch in just about 15 minutes from now. Here's a really good question in a super chat we got from Mans on Mars, and I'm going to ask this to both of you and I'll answer at the end. What is your favorite SpaceX drone ship, and what would you name your drone ship if you could name one?
Oh gosh. My favorite drone ship. I didn't know, like, do people have a favorite? I mean, I think the names are funny, but aren't they basically similar? What?
Yeah,
Well, no, not exactly. No.
I don't think I have a favorite.
that's like asking someone if all the
Who's your
shuttles are
favorite
exactly the
child?
same.
Oh, we don't want to get into that, Sawyer. Come on now.
I think that's the equivalent of saying that, though.
Yeah. I'm ashamed to say I don't think I have a favorite. I'll have to do more research. I don't know.
Well, Julia, who's seen over 100 of these come back, what's your answer?
Oh boy, I'm going to have to go with just read the instructions. That one hasn't had its deck reshaped. In fact, it's gone through a few transformations and it looks rather pirate ship-like to me, with the various cargo containers that just seem to get reconfigured. So it's definitely got a little bit of personality. As far as what would I name a drone ship? Oh my goodness. Uh, Return to sender?
Ooh,
Ooh,
that's awesome. That's a good one. That's good.
that's a really
Why,
good one.
thank you, because that was literally off the tip of my tongue.
Well, well done, then. That's dang, I like that. For mine, I'm gonna go with an unusual answer, and I'm gonna go with, of course, I Still Love You, which started off on the East Coast. It's the OG. It's the original name of the drone ships. It's
I think
one of the
that's my
first.
favorite named one for sure.
Yeah, and the fact that it's now worked dual coasts is really cool, and the fact
Mhm.
that my parents can never say the name properly is also kind of fun. So that's why, of course, I Still Love You has a special place in my heart. And apologies for calling out my parents who are probably watching this stream.
And for anyone who's curious tonight, the drone ship will be A Shortfall of Gravitas, and the recovery ship will be Doug coming in afterwards too. Hello, Doug.
Yeah.
Hello, Doug.
Hello,
You
Doug.
know, I love that we still call Doug a she, though. That just cracks me up.
And I'm being corrected apparently by Alex that technically the OG drone ship is just read the instructions. So it'll always be the OG in my heart. The I guess OG could also be Octograbber, so I need to specify. But anyway,
Oh, of course I read the instructions. That's Das's input on that one. Of course I read
Nice.
the instructions.
oh, a combination of the two. I like it. Yeah, mine would be something something Endeavor clever pun.
Hmm.
I got to come up with a better one. I will. Um. All right. I don't need to keep droning on about the names. Uh, let's take some more of your questions, some of the support. So we have a question from Connor here that came in through a store message. We'll see what you got from the store as well, asking what is the Tempo satellite's main mission? Ooh, very nice. Final for first. Like that one. Alicia, can you just do a quick summary again of what Tempo's mission is tonight?
Yep. So again, TEMPO it stands for the Tropospheric Emissions Monitoring of Pollution. It is an instrument that's going to be on board a satellite that's going to be going around at a geostationary orbit, and it's going to be monitoring pollution. They're going to be looking at particles that are up in our atmosphere and being able to discern exactly what chemicals those are. And they're also going to be able to track it down kind of to a very small level here at 4 square miles. and be able to check it every hour as well. So we're going to be looking specifically for patterns in pollution, and we're going to be looking specifically in locations. So if there happens to be a factory or like a cargo ship or something that's emitting a lot of that, and then also tracking it just over time.
Fantastic.
And actually, I have another great pun. Let's do another one, shall we?
Go for
What
it.
happens? What happens when the pollution goes down in Los Angeles?
I don't know. What?
UCLA.
Oh,
East Coast, West Coast, by the way. Jack, if you're listening.
Oh, boy. That was actually pretty good. I'll give you that one.
All right.
And I do have to give props to all the people in chat coming up with some absolutely fantastic names. Here we go again. Finders Keepers. There's some really clever ones in here. I like it. So props to everyone in chat for coming up with those. We are now less than 10 minutes away from launch, entry, and landing. Wait, why did I say those 3 words in order? Oh yeah, because you can get store purchases from our launch, entry, and landing collection on shop.nasaspaceflight.com. If you forget which engines ignite for each part of the flight, you can always remember by wearing it on a sweater. You've got the launch itself with all 9 engines, the 3 for the entry burn, and then, of course, the single engine for landing. I'm actually pretty proud of my rhyme on that one. That was off the top of my head as well. So, yeah, if you want to drink Loxygen in the morning, or at least drink coffee with your Lox, make sure to head over, get the mug, and all the stuff at shop.nasaspaceflight.com. And don't forget, we also have all of our Starship stuff with the excitement coming up. We'll be doing plenty of streams related to Starship, so you can also get your patch and your gear for that. That brand new patch that looks absolutely amazing and is also one of the emotes or emojis in chat. T-minus 8 minutes now. One of the next big things that we'll be looking out for in the countdown is the engine chill that is preparing the 9 Merlin 1D engines at the base of the rocket, cooling them down in anticipation of the crazy loads they will experience once fuel starts going through it at T-minus 3 seconds. And I guess another thing that you could put in those mugs is T-Teb, or it'd be Teb-T. In that case?
Yeah.
I'm sorry. I had to. In case you don't know, T-Teb is the green flash that you see right around engine ignition. That is what actually ignites the 9 Merlin 1D engines and will also end up lighting the Merlin vacuum engine that powers the second stage. All right. Here's an interesting question from Souls Redacted, saying, why doesn't this mission have the gray band on the second stage like the recent Falcon Heavy missions? Does anyone want to take that, or you want me to take it?
I have no idea.
What they're talking about...
I was going to say, I'm not quite sure what we're talking. I'm trying to think of all of the Falcons I've seen. And if
Gotcha.
Yeah, go ahead, because I'm thinking it has something to do with the hardware configuration, but...
The difference is that this is going into a geostationary transfer orbit. So that means that it's dropping it off into a lower orbit, and the satellite will then put itself into its final geostationary orbit. Whereas the Falcon Heavy last couple of missions have gone direct to geostationary orbit, which means instead of a 20-minute coast phase before satellite separation, it is a 6-hour coast phase before separation. So to prevent part of the vehicle from overheating and basically help manage the temperature in it, that is gray instead of black like we see on the interstage on these Falcon 9s. The more you know, imagine the graphic popping up on the screen. Da, 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 da. We are getting confirmation now that Stage 1 RP1 load is complete. Again, that's the refined kerosene, is one of the 2 propellants that fuel Falcon 9. The next thing that we'll be keeping an eye out for in about a minute and 10 seconds is the strong back retract. That is that giant metallic structure that you see upright against the rocket. There are clamps around that fairing that will move away, and then the transporter erector, the strong back there, will lean back literally a couple tenths of a degree, essentially, to start moving away from the rocket before eventually it completely throws back at T0. So, I guess when do we want to throw it back to? Throw it back to the 90s? Wow, crickets on that one. Okay. I mean, it throws it back 90 degrees. All right, throw it back to the 80s.
There
Best
we
decade.
go.
All right. Fair enough. Well, Julia, we are getting now within 5 minutes, and I know you've got your cameras all set and ready to go. Any final thoughts before you head off for liftoff?
No, actually, I don't have any final thoughts. There is a healthy crowd out here for it being a earlier night, evening, middle of night launch, whatever you want to call it. It's not quite bedtime here on the Space Coast.
All right. Well, we will let you go enjoy the launch, and we'll check back in with you afterwards to see the sound and see how the spring breakers who are down there also get to enjoy the liftoff.
Well,
Boy.
thank you, Sawyer.
Absolutely. Now, as the strong back, you can see the clamps are now moved away from the fairing halves and will start to lean back ever so slightly. By the way, we are being told those fairing halves are both repeat flyers. One of them is on its second flight, and the other is on its 8th flight. And a reminder, this booster is on its 4th flight. Boy, how many different numbers can we throw at you at once, right?
Seriously.
Man,
And I
it's not like
believe this is the 184th Falcon 9 launch from the Space Coast, actually. We just keep throwing out numbers all night.
I love it. I love the facts coming in there. I mean, I can really go crazy with the numbers if you want, but we are T-minus 3 minutes and 33 seconds away from liftoff. Again, that sort of vent stream that you see coming out near that black inner stage, all of that totally, completely normal. Let's see. We are almost 3 minutes away, so we are going to take a quick pause in the meantime on questions and super chats, but you can still send them in. We will read them after we get closer to liftoff here. We are now also getting word, as is again evident by the vent there, the stage 1 LOX load is complete, the liquid oxygen. And that also is indicated by the fact that the vehicle is fully frosty.
Fully frosty. Here we go.
You got any more puns before liftoff?
Actually, I do. I've got one more great one. Ready?
Go for it.
Why does Argentina have the least pollution?
I don't know. Why?
Because they have Buenos Aires.
Oh!
Sorry. Okay,
I
that's really
like
bad.
that. That was actually, wow, that's clever. Mine are just the dumb dad jokes. That was legitimately actually a good one.
I mean, it's tempo. We need the pollution jokes tonight, right? Not that pollution's a joke, guys. Pollution's no joke. No.
Correct. We also don't want to pollute the chat with puns, but anyway, serious presenter now mode as
2 minutes.
I'm being told to stop encouraging
Pull it together. Pull it together.
T-minus 2 minutes now on the clock. The next big things that we will be keeping an eye and ear out for is the call out that Falcon 9 is in startup. That is when the onboard computers will take control of the count, and mostly the vehicle will have control all the way until liftoff. And then at T-minus 45 seconds, we should also get the official go for launch. Oh, also at the 1 minute mark, the flight tanks should all be pressurized to flight pressure. So that's what we're going to be keeping an eye out for in the next 90 seconds as we get closer to liftoff. Stage 2 LOX load is complete. That is once again the nitrogen purging the lines that filled the second stage. So again, totally normal. It will stop before liftoff. And anyway, it's just nitrogen, which is more inert. Coming up on T-minus 1 minute now until the launch of Intelsat 40e and Tempo. We are standing by for the official word now that Falcon 9 is in startup. As soon as we get that, we'll pass that along to you. All right, there we go. Confirmation Falcon 9 is in startup. Any second, we should be getting the final go for launch. And we are now about 30 seconds away. There it is. The launch director has given the go for launch. So we are now 30 seconds away from liftoff. Everything proceeding as planned up to this point. 20 seconds. And again, we will be quiet once it lifts off so that way you can all enjoy the amazing sound that we're expected to get. Reminder, keep an eye out for that green flash of T-Tab, which will ignite the 9 engines right around 3 seconds. 4, 3, there's the ignition. 2, 1, 0, and liftoff. As SpaceX increases its tempo, we get to learn more about how we are impacting our atmosphere. And it has cleared the 4 towers. And at this point, I will let the field microphones take control of the audio and enjoy. And so far, liftoff is proceeding as planned. We should be approaching max Q right about now. That is the maximum dynamic pressure on the vehicle. I think we heard a little bit of sonic squeal as the sound reverberated off the VAB there, I think I heard. As we now have our tracking cameras. In addition to the handheld, we have our robotic tracking cameras keeping an eye on the first stage as it continues into orbit. And is, I believe, our handheld track. I love as it gets to this part where you can see the individual 9 engines. It's not that the thrust itself is changing, it's just that the atmosphere gets thinner, and as a result, the exhaust plumes, which were very held tightly together, start to spread out a bit. Oh, that's beautiful. The next thing that we're going to keep an eye out for are events that will happen in pretty quick succession. So at 2.5 minutes into flight, about 30 seconds from now, we should have MECO, or main engine cutoff, at which point the 2 stages will separate, and then the second stage will ignite in what's known as SES-1. Unlike Starlink, which is immediately followed by payload fairing, this one, the payload fairing, will deploy about 30 seconds after SES-1. Oh, look at that view. Standing by for MECO. And that's MECO, and that looked like stage separation there. Let's see. We had MECO, we have stage separation, and SES-1, that is the ignition of the second or upper stage there, the Merlin vacuum engine. And at this point, the first stage is going to be doing its maneuver to basically orient itself and deploy its grid fins, as you can see on the left side of the screen there, ahead of its landing on the drone ship A Shortfall of Gravitas. And again, we can still see it with our cameras there on the left, unbelievably.
It's such a beautiful night out there. Wow. That's amazing. You guys still have that tracking.
Amazing. Oh,
Yeah,
look at that.
there it is.
There's the Casper
Gorgeous.
or the jellyfish, whatever we want to call it.
Yeah.
Oh, the effects in the
love
atmosphere.
it. Yes.
Oh, some of that is from the gas jet thrusters as well on the first stage, I believe, which is helping to steer it towards its landing. And we should have fairing separation as well. Oh my gosh, that was beautiful. And there we go. We have
Amazing.
confirmation there of payload fairing, jettison. Those will parachute down into the ocean, be picked up by Doug, and be used again on future flights. That view never gets old, right, Alicia?
I know. Yeah, we're lucky too with the just the brightness of the moon and everything too. It's really picking it up tonight. That's awesome.
Yes, and typically the jellyfish is normally around sunrise or sunset, but it's the way that the light, in this case, I guess from the full moon, is interacting with the particles in the upper atmosphere.
It's a moon jelly.
And the fun, you know what? I can't actually even see that from our perspective here on US 1. I can see I can still visually see second stage going, but I did not get to see a jellyfish or a Casper.
Wow, yeah, that is the amazing auto track from our own Michael Baylor, taking care of that. And in case you're wondering, those streaks on the side, those are stars. It's just going so fast that the stars are actually streaking by. And there we go. Everything looking good so far. It looks like the first stage has just reached apogee. That's the highest point, which means it will now start coming down. It reached about 129 kilometers up. It's all down from there, although controlled down as it works its way towards the drone ship. Gosh, those views are gorgeous on the double screens. I know I keep saying it, but it just is.
Just never gets old.
By the way, also of note, besides that, we're getting word that the 8th flight of one of those two fairings, now that it has separated, is now the second fairing half to fly 8 times. So, more records being set. Oh, man. One thing I can say for sure is people are not asking us to be up tempo, but at least tempo is going up.
Womp womp.
The next major milestone that we'll be seeing in about a minute from now, as you mentioned, is that first stage entry burn, which is 3 of the Merlin 1D engines reigniting. And my favorite part is that it essentially uses fire to slow itself down. So it will burn towards the Earth, and as it goes through its own plume and everything, its speed will help decrease dramatically to prepare it for a softer, hopefully very gentle landing. And that burn should last approximately 25 seconds for this flight. In the meantime, that view of the second stage, everything appears to be proceeding as planned, as it is now 16,500 kilometers per hour in speed and climbing. There we go, on the left side of your screen, you can see the entry burn. Again, that lasting about 20 to 25 seconds or so, helping to slow it down. And everything looks good so far. You can see how quickly that speed dropped as well there. And it is going to pick up speed again, but it will have one more final landing burn, and it will also slow down as it gets into the thicker parts of the atmosphere. That's when those grid fins come in, which besides always making me hungry for waffles, help steer it once it gets into the atmosphere. And fun fact, that entry burn is part of the reason why the Falcon comes back as sooty as it does, because RP-1 is refined kerosene, and kerosene is a carbon-based fuel. So as it burns, some of that carbon soot ends up on the rocket itself, and that's why you get boosters that keep getting sootier and sootier.
But they look so cool when they get sootier and sootier too.
They really do. It's hard to say sootier, but yes.
No, I remember the first time I saw one, I was down at Kennedy. I was on a bus, actually, a tour bus, and we pulled up right next to one that was like being shuttled off somewhere. And I was like, why don't they just clean it off? Just hose it down. And now I'm like, oh, no, keep it on. Keep it on. It's so cool.
Exactly. And the weight that it adds is negligible.
Yeah.
So basically nothing. All right, we should be coming up now on MECO, main engine cutoff, any second, which, unlike a Starlink, will actually happen before the landing. And there we go. That is SES-1, excuse me, not MECO. SECO, second engine cutoff. Words. And if you look on the left side of the screen, you can see the landing. You see those grid fins steering as it should pop through the clouds. We should see the drone ship. There it is. Any second now the landing legs will deploy. There they go.
So amazing.
And
sticks the landing. Woohoo!
Touchdown.
Amazing. It never gets old.
Add a -5 to it as the booster is now successfully completed its 4th landing on the drone ship, this time Shortfall of Gravitas. And we should be getting word as well for nominal orbital insertion for the upper stage as well, which will be in a bit of a coast period for a bit here. So while the first stage hangs out on the drone ship, the second stage has one more burn planned. That burn is planned for about 26 minutes after liftoff. And you can see there the satellites on top of the rocket, the Intelsat satellite, which has tempo attached. You know, we were talking about numbers, Alicia?
Yeah, I was just about to say, we just got word this is the 33rd landing on A Shortfall of Gravitas and the 120th launch from Slick 40 at Cape Canaveral. And the 110th landing in a row since the last failure. Yikes. All right, thanks, Alejandro.
Alex coming in
Alex.
clutch in the back channel with those numbers. And as you mentioned earlier, this was the 184th overall landing and 143rd drone ship landing ever between all of the drone ships. Also, the 23rd Falcon 9 family launch this year, by the way.
Also, the 175th launch overall from Pad 40.
And a partridge in a pear tree. Oh man, that sounded absolutely amazing on our stream here. And there is DOS's favorite view, as I will say, the empty launch pad.
We got to say it every time.
Yes. We've got a few things to support that came in during the launch that we want to say thank you to. Michael, thank you, saying really appreciate all the work and dedication to reporting and documenting history in spaceflight. Thank you. Well, thank you for joining us, and thank you for getting some of the new Starship orbital flight test patch gear, getting one of those new patches. Thank you. And then Tyler saying, well, better gear up. Starship is a-coming. And that it is, and grabbing some Starship merch from the store as well, with the orbital flight test t-shirts. And yeah, another one there, the eat, sleep, scrub, repeat, which we normally only promote on a scrub. This one thankfully didn't. So but at this point now, we will continue to update you on the mission through all of our social medias and stuff, and in our article will be updated. But first, I want to thank everyone who joined us here tonight. Alicia, thank you so much for joining me.
Of course. Always a pleasure. Always a pleasure. Great time tonight, and some really great views there as well. Nice clear night. Thanks everyone for joining us tonight and for all the support.
I think the consensus is from chat that we need more of you on stream, so come whenever you're ready.
Thank you. I know. Well, as you all know, I do work at the Intrepid Museum. Shout out to Intrepid. We are very busy. We are, actually, I'll do a quick plug if I may. Coming up April 28th, Friday, April 28th, if you happen to be in the New York City area, we have our astronomy night. It's a free Friday astronomy night, so you can come out between 5 and 9 for free. And check out some cool stuff. We're going to be having Mike Massimino in conversation with Cyan Proctor and Nicole Stott. Cyan Proctor, of course, being of inspiration for, and Nicole Stott, a former NASA astronaut herself. The big theme of the night is actually art in space. So we're going to be talking about their foundations that they started. We've also got a CubeSat exhibit. Cornell Engineering is putting together a CubeSat that's going to have holograms on it to experiment with a light sail. So we've got the artist who helped out with that, who's going to be there, and a bunch of other really great, just activities for the whole family and demonstrations. We've got stargazing out on the flight deck all night. It's going to be a blast. So if you happen to be in the New York City area, come on by the Intrepid, of course, as always, and come see the best space shuttle, the Enterprise. And it'll be fun.
Space, astronauts, and space shuttle? I'm sold.
I know. It's perfect, right? It's perfect. So yeah, come on by, see that, and I'll be around.
Yes. And thank you, Julia, for joining us from the field tonight.
Well, thank you for having me. And by the way, Alicia, East Coast, Best Coast, and Atlantis is my gal. So
Well, I'm an East Coaster, but my heart goes out to Endeavor. Although I did actually work on the Intrepid at one point, so I do have a love for Enterprise as my second favorite baby.
Of course you do. You have to.
Thank you as well, Max Evans, for the fantastic tracking tonight. Absolutely amazing job getting all the way, including parts of the second stage. Phenomenal. Really well done. And, of course, can't forget Patrick, who's been pulling all the levers and pushing all the buttons here tonight, making this stream look as good as it did. And for those unaware, I am Sawyer Rosenstein, and as based on the merch that we just got, I'm sure a lot of people are really excited for Starship as it prepares for launch, so we're going to send you over to our 24/7 coverage of Starbase on Starbase Live. And, thank you for joining us all for this launch, and later, nerds.